In this video, we show how to find a quadratic and power model for a data set using the TI-83 graphing calculator. All right, suppose we are given a data set and the question is to find the quadratic model that is best fit for this data set. All right, so we're going to pull up our calculator. And the first thing we need to do is click on Stat and enter in our data values. All right, so I click Stat, and next I'm going to click Enter. And in the L1 column or first column, I'm going to type in my X values. So 0, enter, 2, enter, and so on. And then I'm going to right arrow to the L2 column and type in my Y values. 0, 4, 0, 1, 15, 6, 3, all right, make sure that you have the same number of data values in both L1 and L2 columns. And next you want to click back on Stat. This time you want to right arrow to Calc. And then you want to scroll down till you find Quadratic Regression, or number 5. And then click Enter. Click Enter one more time. And then you have, the coefficients for the quadratic equation or function. So our quadratic, function is y is approximately 100.21, and they asked us to round to 2 decimal places. So we're going to have here 100.21 x squared minus 1.84 plus 1.50. And with this quadratic equation, we can make predictions. We can use this to make predictions on other x values. Suppose we wanted to find, what the y value is when x is, say, 15. We would substitute 15 in our model here and find the corresponding y value. Right, so we can make predictions. All right, let's move on to question 2. All right, in this question here, they again give us a table of values and they ask us to find a power function that models this data. All right, and then part B says find a linear function that models this data. And then part C is asking us which model gives a good fit, or if each model gives a good fit. All right, so we're going to do the same thing we did in the previous example. That is, we want to, enter in the data, or click Stat first, and then enter in our data. So I'm going to delete the data I had last time. All right, now I'm going to enter 4 in the L1 column, or for the X values here. 4, 6, 7, 9. All right, I'm going to right arrow to the L2 column and type in my Y values. So I got 6.8, 10.9, enter, and then 12.8 and 17. All right, and now make sure we got the same number of values in both columns, and then we want to go to stat, and we want to right arrow to calc. And this time we want to scroll down until we find power regression. Here it is, A, PWR-REG. We want to click enter, and then click enter one more time, and this is going to give us our coefficients for the power function. So that is, let's see, I'm going to write that down here. So for A, that is Y equal 1.4, approximately 1.429 x raised to the 1.128. All right, rounded to the nearest thousandth. And then for part B, we want to do the same thing. You know, we've already entered in our data, right? But this time we want to click on stat, right arrow, go down to linear regression. Number 4, click enter twice, and our linear function is Y approximately 2.035x minus 1.350. All right, and then for part C, it says visually determine if each model is a good fit, right? So in order for us to determine if the model is a good fit, we want to see that when we graph the equation through the scatter plot of the data, we want to see if the curve is going to go through many of those data values. All right, so let me pull up the calculator so we can see this. And the idea is whichever equation goes through most of the data is the better fit for the data. All right, so here I'm gonna go to, okay, I'm gonna go to graph, right? And nothing happens, right? All right, so I'm going to click on second, and then I'm going to click on y equals, or the stat plot function. All right, now my plots are off, so that's why the graph is not showing. All right, so I'm going to click enter, and I'm going to turn it on. Right, so it's blinking on, and I click enter, and now I should have a graph of those data values. Right, so we can see there's only one data value here, right? But in our table above, we had 4 data values. So what we need to do is adjust the viewing window. So I click window, And since our data values don't have there's no negative x values, I can change this to 0 for x min to be 0. For x max, I can leave it at 10 because my largest x value was 9. And I will still count by ones. So I'll leave x scale as 1. My y min, I will change to 0 since I have no negative y values. And then y max, the highest y value I have is 17. So maybe I'll change y max to 20. All right, and maybe I will count by 2's on the y-axis. All right, now when I click graph, we see all 4 data values, right? And those data values appear to be in a straight line, so it looks like a linear model would be a good fit for this data. But in order to find out for sure, we can go ahead and graph the line, that linear equation through this line, through this scatter plot. So to do that, we click on y equals, and we type in the function. In other words, 2.035 x minus 1.350, and then we're going to click graph, and now we can see that straight line drawn through the scatter plot, and that straight line looks like it hits the data values at 3 locations, or 3 data values here. So the linear model is a good fit. Now if we also want to check on the power model, we can go ahead and type in the equation for the power model here in Y2. So that is 1.429 x raised to the 1. And then graph this. So you can see that power model is a little curved, but this also is a good fit, for the data. So both models are a good fit for the data. And probably we would need more data values to determine which is a better fit, but having only 4 data values based on these 4 and based on the curve that we drew here, both models are a good fit for the data.